This video is going to be about the law of sines, which helps us solve for sides and angles of non-right triangles. If you look here in the middle of the page, we have an example of a non-right triangle. You'll notice angle A is across from side little a. Angle B is across from side little b, and angle C is across from side little c. The law of sines says that the sine of angle A divided by side A is the same as the sine of angle B divided by side B, or sine of angle C divided by side C. Because these are ratios, you can also flip the fractions if it's more convenient, as you see at the bottom. So we have side over sine, rather than on the top, sine over side. Alright, so here we have a first example with a definitely not right triangle. We've got an angle of 71, 73. We could find the last angle, but we really don't need to. The first thing we should do is label our sides and angles. Now, it really doesn't matter which angle we call A, as long as the side across from it is little a. Let's get a better color. So here's angle big A, side little a. And then it doesn't matter which angle we call B, as long as little b is right across from it. That would leave the last angle as angle C with little c, but we're really not going to care about C at all because we don't know the angle, we don't know the side, and we're not looking for it. So the next thing to do would be to set up the formula of the law of sines. So I'll just rewrite it here. Little a over sine of A equals little b over sine of B. Again, I could add little c over sine of C, but we really don't care. And then I'll just put in what I know. I can see that x is little a. Sine of A is going to be sine 71. Little b is 90. And sine of B is going to be sine 73. I now need to go to the calculator to actually simplify sine 71 and sine 73. So sine 71 is 0.95 over 90. Sine 73, pretty similar, 0.96. Last thing to do, cross multiply. So we have 0.96x equals 90 times 0.95. To get x all alone, I'll divide both sides by 0.96. And I'm just going to stick this whole right side into the calculator at once. So you end up with 90 times 0.95 divided by 0.96. And x ends up equaling 89.06 inches.
Trigonometry!
Here's a second example. This time, instead of looking for a side, we're actually going to be looking for an angle. Angle x. So again, the first thing I'm going to do is label my sides and angles. So I'm going to say that x, I'll call it A, which means that across from x, 60 is little a. I'll call this other one that we know 125b. So across from b, we have little b. So again, we will have 60 over sine x. Now I'm just going right ahead and putting in the numbers I know rather than a and big A. So 60 was my big A, x is my angle A, and then I know 100 over sine 125. Again, 100 being my little b, and 125 being my angle B. I'm going to do one simplification with the calculator, rewriting as 60 over sine x equals 100 over 0.82, and then cross multiply. So we have, I'm going to go over this way, so 60 times 0.82 equals 100 sine x. So I'll go ahead and simplify 60 times 0.82. We have 49.2 equals 100 sine x. Now, we're trying to solve for x, so I'm going to get rid of that 100 since it's crowding in on the x. Whoops, not 1,000, just 100. All right, so then 49.2 divided by 100 gives me that the sine of x equals 0.492. Now remember, when you know the sine and you're looking for the angle, you need to use the inverse sine. So I'm going to do second sine, which will give me the inverse sine, 0.492, which makes x equal to 29.5 degrees. And now I'm all done. So I think an important question here is, when is this used? How do you know when to use this versus the SOHCAHTOA or some other rule? Well, the first clue is going to be that you don't have a right triangle. If you have a right triangle, most likely go with SOHCAHTOA, by far the easiest. The other two cases when the law of sines is used is when you know a side, and an angle. Notice that the angle is not included between those two sides. This is like the example we saw in example 2. Another time you'll use it is when you know an angle, and a side in that order. Notice again, side not included between the two angles. This is like what we saw in example 1. For homework, I'd like you guys to try these two problems. Number 1's pretty straightforward, a lot like example 1. You're looking for a side. Number 2, I would like you to do two different things. I'd like you to find x using both the law of sines, such as in example 2, because you're solving for an angle, and see if you can do it using SOHCAHTOA. Notice I've put in the height of this triangle there. See if you can solve for that and then use that to find x. Good luck.